A laboratory randomly tested 87 chicken eggs and found that the mean amount of cholesterol was 233 milligrams. Assume that sigma, which is the population standard deviation, is 18.6 milligrams. Construct and interpret 95% confidence interval for the true mean cholesterol content mu of all such eggs. So what we are going to do, we are going to construct a confidence interval for the mean of the population mean, right? And you remember this is from our earlier discussion in the earlier video, that in this situation we are going to use a z distribution, right? Why? Because we know the population standard deviation. The population standard deviation is known, so we are going to use a z distribution. So this is one of the things which I told you in the earlier video, that which distribution needs to be used, right? So in order to solve this problem, we will solve this by using 4 steps. So let's start the step number 1. In the step 1, what we do in step 1, we check the basic requirements. Let's write them. Basic conditions or basic requirements. We want to see that whether the basic conditions are met or not. Without these basic conditions, we cannot construct a confidence interval. What was those basic conditions? Let me write that. The first one was you need to have a random sample. You need to have a random sample. We will check these conditions. Random sample. Number 2, the second condition was sigma known. The population standard deviation must be known. And our third condition was that either n is greater than or equal to 30, the sample size is greater than 30, or the population is normally distributed. These are the 3 conditions that needs to be checked before we can compute, we can construct a confidence interval. What happens most of the time, I see the student don't care about these conditions, these basic conditions, and they just start computing or constructing the confidence interval. And if you apply a theory in such a way without basic conditions are met, your results, you will get a result, but your results will not be accurate. So this is very important you understand that. So let's check these conditions one by one. Let's check the first basic random sample. Look at that, randomly tested. So we have a random sample. Sigma known. We know sigma. Sigma is 18.6. Look at that. So second is also met. Either the sample size, look at the sample size. This is 87 and this is n. And this is n. Our n is 87 and this is definitely greater than 30. So I don't care about the parent population as long as we have sufficiently large sample size. And for this problem, it look that 87 is a large enough a sample. So the sample size is greater than 30. Remember, either the sample size is greater than 30 or the population is normally distributed. If any one of this condition is met, then the basic requirement number 3 is met. And you see the third condition is also met. So all the basic requirements are met. So we are happy with the step number 1. Now we are in a position to construct the confidence interval. So let's see what is the second step. In the second step, what we do, step number 2. Let me write step number 2 now. In the second step, we decide the confidence level. Decide confidence level and choose critical value. Now note that our confidence level is clearly mentioned here, 95%. That's the only thing which contains a percent sign, and that is a confidence level. So I have a confidence level is equal to 95%. And recall from my earlier video, if the confidence level is 95%, then our critical value, which we call it as a Z star, it's equal to 1.96. If you don't know what I'm talking about, you can check my earlier video where I talk about that corresponding to a certain confidence level, what is the critical value. So we are in a position to decide the confidence level, and we are in a position to choose corresponding critical value. The second step is also good. Let's go to the third step. What is the third step? In the step 3, this is the most important step, step 3. Most important step, and I see the students have a lot of difficulty in this particular step. These two steps are easy, but this is a step difficult. In this step, we find margin of error. What we do? We find margin of error, and fortunately we have a formula for that. The margin of error is equal to a z star multiplied by sigma divided by the square root of the sample size. This is the formula to find the margin of error. We represent the margin of error by E. We represent the margin of error by E, and it has this formula: z star times the population standard deviation divided by the square root of the sample size. Let me plug in the values. We have everything here. You note that we have the value of z star. It's 1.96. We have the value of sigma, which is 18.6, and we whole divided by square root of the sample size, which is 87. So when I plug in these values and I use this computation, my answer comes out to be 3.91 rounded to the 2 decimal places. This is my margin of error. This is the margin of error I have computed. So we are done with the step number 3. Make sure you compute this correctly. You don't make any mistake here. Let's go to the last step, step number 4. So what we do in step number 4? Step 4. In step 4, we write our final answer, the confidence interval. The confidence interval is, the CI stand for the confidence interval is, it's a sample mean plus minus the margin of error. That's how we write the confidence interval. I repeat, the confidence interval is the sample mean plus minus the margin of error, or I can even write it like this: the sample mean minus the margin of error, comma, sample mean plus the margin of error within these parentheses, just to show the confidence interval. Just plug in the values. We have 233 minus, sorry about that, minus 3.91 and 233 plus 3.91. So if you simplify this, the answer comes out to be 229.09 and 236.91. Right? This is the margin. This is the confidence interval. So this is the confidence interval. This is the 95% confidence interval. And this is very important that you interpret this confidence interval in a correct way. Now, this is very important that you interpret the confidence interval in a correct way. And how we are going to interpret this confidence interval, I'm going to show you this result, and I'm going to show you the interpretation on the next page. So I told you this is very important that you interpret the confidence interval in a correct way. So how we are going to say that we are 95% confident that the mean amount of cholesterol of all such X, now this all such X mean we are giving a statement about the population, is in this interval 229.09 and 236.91. Remember, I'm not telling you what is the mean content. What is the mean? What is that value? I don't know. It's very important that you understand that. What I'm saying that value lie in this interval, and I'm 95% confident about this. So this is very important that you interpret this confidence interval in a correct way. I repeat the interpretation. We are 95% confident that the mean amount of cholesterol of all such eggs lies in this interval 229.09 to 36.91. It means I'm not telling you what is that mean amount of that cholesterol of all such eggs. I don't know what that amount is, but what I know that amount of that mean amount of that cholesterol will lie in this range, and I'm 95% confident about that. What is the another way of saying this? It means that if I construct 100 such intervals, then 95 of them will contain the true population content, and maybe 5 of them may not be able to capture that mean content mean content of cholesterol of all such eggs. This is another way of understanding this particular confidence interval. I repeat this once again. If I construct 100 such interval, then 95 of them will contain the true population content of the cholesterol, and maybe 5% of them, maybe 5 of those interval may miss that the content, mean content of the cholesterol. So I hope you understand this. Now what I'm going to do, I'm going to show you how you can do this by using another technology which is called StatCrunch. Let's see. So I already launched a StatCrunch, right? So what I'm going to do in order to do this confidence interval, we go to the stat and we go to Z stats, and we go to the one sample. And in the one sample we have, do you want to computation with the data or with the summary? We don't have actual data, we have the summary, we have the mean and the standard deviation. So that's the meaning, that's the difference between you can make a computation with data or with summary. So if we have a raw data, then we can do the computation by using the raw data. But if we have a summary, in this case we have a summary, so we use a with summary. Now when we launch this, when we click this, we get one sample Z summary, right? So first he is asking, what do you want to perform? Do you want to perform a hypothesis test, or do you want to perform a confidence interval? I want to perform the confidence interval, and this is the 95% confidence level. If I have a different confidence level, I will change this value. My sample mean was 233, standard deviation was 18.6, and the sample size was 87. You just plug in and you click you plug in all these values now, and you can also make a graph confidence interval plot. Let's do that, and we hit compute. When we do the computation, look at that, we have a sample mean, we have a standard error. This is the standard error of the mean, 1.9, and what is the lower limit? It's 229.09, and what is the upper limit of the interval? 236.91. It's the same value which we were getting in our previous result. And you can also see the graph. Look at this graph. We have constructed a confidence interval. This is the true population mean, right? And everything is visible here. So this is a 95% confidence interval. So I hope you understand this. You can create this by hand computation, or you can use technology, and the technology which I told you in this case was a StatCrunch. I hope you understand. Thanks for watching.